Hey guys, today I'm going to show you how to integrate using trig identities. These identities allow us to replace trig functions that we don't know how to integrate with trig functions that we can integrate. So here we have a list of all the key identities. We have sine squared plus cosine squared equals 1. And then next we have 1 plus tan squared equals sec squared. And we can derive this equation by dividing both sides of the first one by cosine squared. Then we have 1 plus cot squared equals cosec squared, which we can derive by dividing both sides of the first equation by sine squared. Next we have the double angle formulas right here, and at the bottom here we have two equations that are particularly useful for integrals because sine squared and cosine squared come up quite frequently in terms of integration, and so using these two identities will allow you to integrate them very quickly because cosine 2x is easy to integrate. So we're now going to look at how to integrate using these trig identities, and I'm going to keep them here on the screen just for your reference, but ideally you want to learn as many as you can so that the process becomes a bit quicker. So let's start off with the integral of tan squared x dx. So whenever we have tan squared inside of an integral, you always want to consider this second identity here, 1 plus tan squared equals sec squared. And the reason for that is because sec squared x is, or the integral of sec squared x is a standard integral. So if we can replace tan squared with a standard integral that we know how to integrate, then that's going to make the integral much easier. So this would become, if we take 1 from both sides of this equation, this becomes the integral of sec squared x minus 1 dx. And then we can split this into two separate integrals. So that's going to be the integral of sec squared x minus the integral of just 1. And again, this is a standard integral. The integral of sec squared is tan x. And the integral of 1 is just x. And because we have an indefinite integral, then we have to add the plus c at the end. And so just to reiterate, whenever we have tan squared inside of an integral, then we always want to consider this identity 1 plus tan squared equals sec squared, because this will allow us to replace tan squared with what we know is a standard integral. For our next example, we have the integral of cosine 2x over cosine x minus sine x. The identity that we need to use in this case is going to be cosine 2x equals cosine squared x minus sine squared x. So if we plug that in, our integral becomes cosine squared x minus sine squared x over cosine x minus sine x. And the reason that we've made this, or the reason that we've used this identity, is because now we have a difference of two squares in the numerator. We can actually factorize it as the product of cosine x plus sine x multiplied by cosine x minus sine x. So if we expanded out the numerator here, we would end up with cosine squared x minus sine squared x. But because we factorized it, this allows us to cancel a factor of cosine x minus sine x from both the numerator and the denominator. So when we cancel these two factors, then we're left with the integral of cosine x plus the integral of sine x. And the integral of cosine x is positive sine x. The integral of sine x is negative cosine x. And we have the plus c at the end. Okay, next we have the integral of 1 over sine squared x cosine squared x. And what we need to pay attention to in this example is the similarity between the denominator here and the right hand side of this identity. So if we rewrite this integral as the integral of 1 over sine x cosine x in brackets squared, then we can rearrange this identity for sine x cosine x and then plug it in, and then plug in what we get. So if we divide by 2, we get sine x cosine x is equal to a half sine 2x. So if we make this substitution, then our integral becomes 1 over a half sine 2x squared. And so if we were to expand the brackets here, we would end up with a quarter in the denominator. So if we bring that out to the front, that's 1 over a quarter, or in other words, 4 times the integral of 1 over sine squared 2x. 1 over sine is the same thing as cosec, so this is equivalent to 4 times the integral of cosec squared 2x. And the integral of cosec squared is a standard integral, it's minus cot x. But because we have cosec squared 2x, we have to divide by the inner derivative, which is the derivative of 2x. So we're dividing by 2. And then we're multiplying that by the standard integral minus cot 2x. So our answer becomes minus 2 cot 2x plus c. For our last integral using trig identities, we have the integral of 1 plus cosine to the power 4x over cosine squared x. And the trick that we're going to be using to solve this integral is, because we have a sum in the numerator, we should ask ourselves, if we were to split this sum into the sum of 2 separate fractions, would these 2 new fractions be more easy to integrate? And in this example, that's definitely the case. So if we split this into the integral of 1 over cosine squared x plus the integral of cosine to the power 4x over cosine squared x, then the integral on the left is, again, we've seen it before, it's the integral of sec squared. So the integral of sec squared we know is a standard integral. And then on the right we have a cancellation. We have the denominator cancelling with a power of 2 in the numerator. So we have the integral of cosine squared x. And like I mentioned at the beginning of the video, this is a very easy integral if we use this identity right here. So again, the integral of sec squared is a standard integral, it's tan x. And the integral of cosine squared x is the integral of a half times 1 plus cosine 2x. So if we start by factoring out the half to the front, and then when we integrate, we're left with the integral of 1 is x. The integral of cosine x is sine x, but because we have the integral of cosine 2x, we have to divide by the inner derivative. So we're dividing by 2, and we get a half sine 2x. So our final answer is tan x plus a half x plus a quarter sine 2x plus c. Hey guys, thanks so much for watching. I hope you found the video useful, and if you have any comments or questions, post them down below, and I'll see you next time.